Hello students, physics class 12, electric flux and Gauss theorem, video number 4. In video number 4, we read about intensity of electric field due to uniformly charged wire of infinite length. We find out this is very important proof. By the Gauss theorem we prove it. Suppose this is any wire. Suppose this is any wire of infinite length. Infinite length है यहाँ तक you can see it is given plus q charge, so plus q charge is spread all over the length, and to find out the intensity of electric field at any point t at a distance r. So since it is given plus q charge, electric line of force emit, and we have to find out the intensity of electric field at point p, and to find out the intensity of electric field at point p we draw closed Gaussian surface. But in this, since the length of this wire is infinite, so we don't draw a spherical surface, because due to infinite length, when we draw a spherical surface, length is not covered. It is not totally covered. That is why we have to take, we suppose this wire as an axis and draw a cylindrical surface. Some length is covered. Infinite length we don't cover, but some length is covered when we draw a spherical cylindrical surface. This is cylindrical surface having length L and radius R passing through point P. This is called Gaussian surface. But when we draw a cylindrical surface, this is a special case, that is why proving it. When we draw cylindrical surface, there are three surfaces happen. Two are area of cross section surface, two are spherical surface, and one is curved surface. So we have to take a small area on all surfaces and find out the electric flux through the small area, and then we add them, that total electric flux is come. So when we take a small area on the curved surface and see this is dA, the direction of the electric field is this, intensity of electric line of force, and the direction of area vector is just perpendicular. So they are same. But when we take a small area on this, the direction of the electric field is this, and the direction of area vector is perpendicular to the surface area. Since this is horizontal, that is why the area vector is perpendicular, angle between them is 90. So the electric flux pass through this small surface 0. And also when we take a small area on this curved surface, the area vector is this and electric field is this. So the electric flux is also 0 due to curved surface. Only the electric flux pass through the curved surface. The electric flux pass through the spherical surface, both the spherical surface 0, because dA and E vector are perpendicular to each other. Cos 90 is 0. So the net electric flux pass through this closed surface, that is phi E, is equal to integration of E dot dA, only curved surface, and the value of phi is q upon epsilon naught by the Gauss theorem, you know that, and E dA cos 0 due to the curved surface. Cos 0 is 1, q upon epsilon naught, E is come out, integration of dA, cos 0 is 1, and integration of dA means area of this curved surface, that is 2 pi r. Integration of dA is 2 pi r, that is the area of curved surface. L is length, r is radius, L is length. So q upon epsilon naught E and 2 pi r L. Putting the value, find out the value of E. E is equal to 1 upon 2 pi epsilon naught q upon r L. This is the provement. But in place of q upon L, we can put linear charge density. Since the charge is spread all over the length, that is why we take linear charge density in wire, q upon L. So intensity of electric field 1 upon 2 pi epsilon naught q upon L, q upon R, q upon, in place of q upon L we put lambda, that is the linear charge density, 1 upon 4 pi epsilon naught lambda upon R. Okay, this is the provement of intensity of electric field due to uniformly charged non-conducting, due to uniformly charged wire of infinite length. Now next proof is the intensity of electric field due to uniformly charged sheet, non-conducting sheet of infinite expansion, non-conducting sheet of infinite expansion. Infinite expansion, but means its length is infinite and birth is also infinite. That is very important proof. These two proofs are very important. Suppose this is uniformly charged sheet of infinite expansion. It is given +2 charge. So +2 charge is spread all over the surface of the sheet. This sheet is this type, but making on the board this type. So you can understand this sheet is this, and we have to find out that since +2 charge is given to this charge is spread all over the surface. We have to find out the intensity at point P at a r distance from the sheet. Since its length is infinite and birth is also infinite, so we don't draw a spherical surface or cylindrical surface. In this condition, we have to take another point on the other side, same distance P dash, other side, and take a small area around P, and also same area around P dash, and draw cylindrical surface. Some area is covered. Infinite area we don't cover, but some area of this sheet is covered. Now we find out the electric flux passed through this closed surface. The direction of E vector is this, and the direction of dA vector is this. On this surface, the direction of electric field is this. Electric line of force coming out, and area vector is perpendicular to the surface. You know that. And on curved surface, the direction of electric field is this, and the direction of area vector is, they are perpendicular. On the curved surface, the direction of electric field and dA vector is perpendicular, but on the spherical surface, the electric field, intensity of electric field and area vector are same direction. So the electric flux passed through this closed surface is integration of E dot dA and also E dot dA. Phi is, you know that Gauss theorem, by the Gauss theorem, phi is equal to Q upon epsilon 0 plus integration of E dot dA. That is on the curved surface, but it is 0. On this surface, EdA cos 0. On this surface, again EdA cos 0. On this surface, EdA cos 90. Cos 90 is 0. Q upon epsilon naught. Cos 0 is 1. E taken out dA. Cos 0 is 1. E taken out dA. And Q upon epsilon naught. E A. E A. Integration of dA is A. E into 2A. 2A. So Q upon epsilon naught. 2A. And E is Q upon 2 epsilon naught A. This is the intensity of electric field at any point due to uniformly charged non-conducting charge sheet of infinite expansion. And if surface charge density of this sheet is nu is equal to Q upon A. So the intensity of electric field is equal to nu upon 2 epsilon naught. You are saying it does not depend upon the distance. Only this electric field does not depend upon the distance. That is the movement of this. That is very important. And now last movement of this intensity of electric field due to two charge sheet of infinite expansion. Suppose these are two charge sheet. When they are same charge and then they are opposite charge. Suppose they are same charge, when they are same charge, we have to find out the intensity. We use before formula. At point P, the intensity is due to first sheet, due to second sheet. The direction of this sheet is just away, E1, and the direction of this sheet is just away, E1. E1 is nu upon nu1 is the surface charge density of this sheet, nu2 is the surface charge density of this sheet, nu1 upon 2 epsilon naught, E1, E2 is nu2 upon 2 epsilon naught. Then they are same charge between point P. Since E1 and E2 are in opposite direction, so the resultant intensity is E1 minus E2. That is the difference. And when E1 and E2 are equal, E is equal to 0. When they are made of same material, intensity is 0. And when you find out outside any point P dash, Q, RQ dash, Q, RQ dash. So the intensity of electric field due to this just away from charge E1 and due to second just away from charge E2. And same direction. Similarly, point Q dash, E1 is and E2 is also same direction. So the intensity is E is equal to E1 plus E2. Adding them, nu1 upon 2 epsilon 0 plus nu2 upon 2 epsilon 0. 1 upon 2 epsilon 0 is a common, nu1 plus nu2. And when they are same material, nu1 is equal to nu2, nu1 is equal to nu2 is equal to nu. When we put nu plus nu2, T2 cancel out, nu upon epsilon naught. Just outside, intensity is this. And when they are opposite charge, suppose this is first sheet, and suppose this is second sheet, this is positive, and this is negative. So between the intensities, this is first sheet and this is second sheet. Due to first sheet, the direction is this, and due to second sheet, the direction is also same. So the resultant is E1 plus E2. That is the same process, and the intensity between two opposite charge sheet is nu upon epsilon 0. And when we see outside at point Q, RQ dash, the intensity is due to first sheet is E1 just outside and E2 is inside towards, and due to this sheet outside and due to this sheet towards, they are opposite direction. So the resultant is E1 E2 and E1 minus E2. When they are made of same material, E is 0. Okay.